All right, this lesson is called Proofs of Parallelograms. We're not really going to prove anything. Okay, the name of it's a little misleading. I understand why they do it, but so don't worry about that word proof. But we are going to talk about parallelograms. Today's lesson is going to seem very, very similar to what we've done in the past, but it's got a little bit of a twist to it, okay? A little bit of a change. But a lot of the stuff that you're going to learn today, you're like, Mr. Hamrick, you've already taught that stuff. Well, yeah, I kind of have, but there's a little different take on it. You'll understand what I'm talking about after I do one of these. All right, let me ask you this. This thing that I just drew right there, what is that? Is it? It's a square? It's a rhombus? It's definitely not a square. It's not a trapezoid. It's not. It's a quadrilateral. Very good. Okay. Io said it's a quadrilateral. Really, that's the only thing that we could say about this right now. All right, because I haven't marked anything. I haven't told you anything about the sides. I haven't told you anything about the angles. Would you agree? So I haven't said anything about this. All you see in front of you is a four-sided figure. Now, it sure looks like what? It looks like a rectangle? That looks like a rectangle? Are you just being silly or are you serious? That looks like a rectangle? No. Look, can't have an oblique excuse me. You can't have an oblique rectangle because a rectangle must have what?
Four sides.
Not just four sides. Come on, you guys. Four right angles, thank you. All right. That right there would be a rectangle. Okay? This right here, the only thing that we know give you one chance. When I sent you out before, I didn't write you up. But every time now that I send you out of this room, I'm going to write you up at least an after-school detention. If you get too many of those, it'll be suspension. So control yourself, please. Thank you. So this thing right here, the only thing you know just by looking at this is it's quadrilateral. There's four sides. But what if I did this? What if I said that these two sides were equal to each other and these two sides were equal to each other? Now what do you think I could say about this? I'd say what? Isosceles? Not really. It's a parallelogram. That's right. Because what did we say earlier? We said in another lesson, when you have a parallelogram, if I told you that that thing was a parallelogram, what was true about the opposite sides? They were what? They were equal to each other, okay? So now what we're doing is this. The old way, I'll put old way, or the old theorem says if it's a parallelogram, so they started with the knowledge that this was a parallelogram. They told you, not on this one that I did, okay, but the old way, they said if it's a parallelogram, then the opposite sides are equal. Everybody see that? That was the old way. So if I told you at the beginning, this thing right here is a parallelogram, then what could you say about the opposite sides? You could say that they're equal to each other, correct? Everybody got that? But this lesson is a little different. This is the twist. This is the little change of pace, okay? It's a little bit different. So this, we didn't know that it was a parallelogram to begin with, all right? It kind of looks like one, right? I would guess that it would be one, but I didn't know for sure that it was a parallelogram. But they told me that the opposite sides were equal to each other, all right? So what happens when you have a quadrilateral and the opposite sides are equal to each other? What is this thing now? It's a parallelogram. So the new way, all right, I don't think I've ever said this before, old way, new way, but it just popped in my head, all right? So the new way says if, I'm not going to write this part out, but it says if it's quadrilateral, okay? And if it's quadrilateral and the opposite sides, so if the opposite sides are equal to each other, then what is it? If you got a quadrilateral, the opposite sides are equal, then what is it? It's a what? It's a parallelogram. So it's a parallelogram. Do you see the difference? The if and the then are completely different. What is the if up here? If it's a what? Parallelogram. What's the if on this one? If the opposite sides are equal. Do you see that? That's different. So this one says, if you know it's a parallelogram to begin with, then that means that the opposite sides are equal. Okay, we've already done that. We've had a quiz on it, all right? This new way says, okay, you got a quadrilateral, four-sided figure. If the opposite sides are equal to each other, then guess what this is? Then this is a what? Parallelogram. Do you see the difference? All right. So if the opposite sides are equal, then this is a parallelogram. You can just call it ABCD. All right. So if I know that this and this are equal, and this one are equal, that means that ABCD is a parallelogram. And that's what we're trying to do. We're just trying to decide, with the information that they give us, is that thing a parallelogram or not a parallelogram? That's basically what we're doing today. All right? So let's do another one. This next one, we haven't really talked about, but this is kind of this is a little bit new for us. All right? It's a combination of two things we already know, but it's kind of interesting, I think. So this one says, let's do it in a different color. Now, just sitting here right now, when I have that on the screen, looking at that, can you say that that's a parallelogram? No, because they didn't tell you anything about it, right? You don't know that the opposite sides are parallel. You don't know the opposite sides are equal. You don't know anything about it. You just know that it's a quadrilateral. That's all you know. But what if I told you a couple things? What if I told you that this side and this side were equal? Is that enough to say that that's a parallelogram? No. You need two sets, okay? But we've already done that one, right? But they're going to give you some other information. They're also going to say that these same two sides that are equal are also parallel to each other. So that's all they tell you. They don't tell you anything about that left and right side, okay? They don't tell you if they're parallel. They don't tell you that they're equal. The only thing they tell you is this top and bottom one are equal and parallel. Well, according to this theorem that we're doing right here, that's enough. That's enough to say that this thing right here, we'll call it ABCD again, that's enough to say that this is a parallelogram. So here's what it says. Here's what the theorem says. It says if one pair, Sincere, is it you got to go to the bathroom? Really? I'm right in the middle of this. You can't wait. You can't wait. You got to run out. You got to run out right now. Good morning. You can? All right, that's perfect then. If you can hold it, then that would be great. You should only leave. It's a complete emergency. You just can't hold it anymore. I've been there. I've been in classes, right? When I was in second grade, here's a story. You going to listen to this story? When I was in second grade, I had to go to the bathroom so bad, I just knew I was going to go right there at my desk, right? And the teacher wouldn't let me go, right? He says, no, you should have gone. And I was like dying. I knew I was just going to just go right there. And so I said, well, can I go to the nurse? And I guess the teachers couldn't say, no, you can't go to the nurse, right? So I asked to go to the nurse. I ran to the nurse's office. I said, can I use your bathroom? Yes. And that's how desperate I was. So I know what it's like. I know what it's like to have to go to the bathroom. So if it's an emergency, it's fine. But if it's not, just hold on. Plus, it's a little shorter class today anyway, isn't it? All right, here we go. If one pair of opposite sides are both parallel and equal, you could put the word congruent in there if you wanted to. Equal just is a little bit easier. Okay, so do we have that situation? The opposite sides, I should say, of a quadrilateral. All right, because we got a quadrilateral, correct? I got one pair of opposite sides, and what's true about those two pairs, or what is true about that one pair of opposite sides? They're both what? equal, they're parallel and what? And equal. All right. So that means, so if that's true, is that true here? Yep. Then guess what? This thing is a parallelogram. That's right. Then I'll just write it like this. Then you have parallelogram ABCD. Okay? Getting the hang of this? So you start off not knowing anything about that quadrilateral. Then they tell you a couple things about it. All right? So if the opposite sides are equal to each other, all right? If the opposite sides are equal to each other, then it's a what? Parallelogram. If you have one pair of opposite sides that are both parallel and equal, I don't even have to know anything about the other two sides. If I just know that, then guess what's true about this thing? Then it's a what? Parallelogram. You see what we're doing? We're going to do it a couple more times. All right? Oops, let's do this. So let's put this thing right here. Again, I'm going to ask you this every single time. Do we know that this is a parallelogram right now the way it sits? No, we don't. Okay, but they do tell us a couple things. All right, and what do they tell us this time? This time they tell you that this angle is equal to this angle, and this one is equal to this one. Is that familiar to you? Yeah. Should be. All right, because we had a thing that said, if we know that it's a parallelogram to begin with, then what's true about the opposite angles? The opposite angles are equal to each other, correct? All right, this is opposite. What does this say? If you have a quadrilateral, I'll just write that in there, I should. If a quadrilateral you probably already wrote that down, so I'll just say it like this. If a quadrilateral has equal, let's throw opposite in there, opposite equal angles, then, and does this have opposite equal angles? Yeah, the angles that are opposite each other are equal to each other. Then guess what this thing is? We'll call it ABCD again. I'll just call it the same thing every time. Then we have a parallelogram, ABCD. Everybody good with that? All right. Do you see how it's similar to what we did earlier? Right? But it's a little different. Right? Before, they told you it was a parallelogram. So you could say a bunch of stuff about the sides and the angles and all that kind of stuff. This time, they don't tell you it's a parallelogram. They just say, here's a four-sided figure. But they give you some information. They say the opposite angles are equal. Well, that means if the opposite angles are equal, that means it's a what? Parallelogram. And that's what we're trying to do. We got one more. All right, let's move that up here. Put another one here. What am I going to ask you first? Do we know? Good. Do we know that that's a parallelogram? Do we? No, because they didn't tell you anything about it. All right? They didn't tell you it's a parallelogram. They didn't tell you any sides are equal. They didn't tell you anything. But what we're going to do is this. What are these things called I just drew right there? Starts with a D. Diagonals. They're diagonals. Okay? These are diagonals. So, I mean, every quadrilateral can have diagonals. But what's special about these diagonals? Well, they're not equal to each other. Now, these two segments right here are equal. See, from here to here and here to here. So that means it's being what? Bisected. Very good. And what happens with this other diagonal? They're also being bisected, okay? It does not mean that this diagonal is equal to this diagonal. That is not necessarily true. Everybody got it? All right, but they are being bisected. So if they're being bisected, guess what this quadrilateral is? It's a what? It's a... No, it's a what? It's a parallelogram, right? We've been saying this. It's the fourth time we've done this, okay? So it's a parallelogram. So if the diagonals bisect each other, Now, the one thing I left out the word quadrilateral in here, but it's kind of assumed, right, that we're talking about quadrilaterals here. So if the diagonals bisect each other in a quadrilateral, if you want to write that, that's fine. I'm just shortening it a little bit. So if the diagonals bisect each other, then what do we have? We got a parallelogram. And how do I write that? I put that little symbol that looks like a parallelogram, and then I go A, B, C, D. We go to this? All right. So again, at the beginning, we didn't know it was a parallelogram. Okay, we didn't know what it was. We knew it was a quadrilateral. It had 4 sides. Okay, that's the only thing we knew. But then they put the diagonals in there. I mean, you could put diagonals in any quadrilateral. But what was true about those diagonals? They did what to each other? They bisected each other. All right. So this little segment and this little segment are equal. This one right here is equal to this one right here. So they bisected each other. So if the diagonals bisect each other, then guess what's true about that quadrilateral? Then it's a parallelogram. That's right. Everybody good with that? So let me go a step further. So now we know that this is a parallelogram. What else do we know is true? We know that AB would equal what? Now we know it's a parallelogram, right? So now we know that the opposite sides are equal to each other. What else do we know? The opposite angles are equal to each other. And since it's a parallelogram, the opposite sides are also what? Parallel to each other. We already said equal to each other. Okay? So we know all that stuff. Now that we know it's a parallelogram, we know all that stuff. Sincere? You got to go? All right. Bring me a pass. All right. Let's do a couple examples and see what they're going to ask on the homeworks, on the quiz, on the test, that kind of thing. Why don't you go to the office and get a book, okay? Because I'm going to stop writing passes if you guys don't have your book. And tuck your shirt in, please. All right, here we go. Let's do some examples. So I'm going to draw. These look a little different. These parallelograms don't look exactly like... Oops, let's make it white. They don't look exactly like what we did before, but it's pretty close. Let's change this to that. Now let's change it the other way. I'm just trying to make it look like what it looks like in the book. I don't even know if it's how it doesn't really matter, to tell you the truth. Just wasting time. All right, they just slant it a little bit. It's no big deal. You could draw it any kind of way. Won't make any difference. So they call this D, E, and then F and G. Okay, so check this out. Oh, did we miss one? No, but we could still do this. All right, I'm going to ask you this question again. I've asked it like 4 times already today. Is this a parallelogram the way it sits right now? We don't know. I mean, it could be, right? But we don't know. We don't know for sure. But they got to tell you some stuff. They tell you that this and this are equal. Is that enough to say that that's a parallelogram? No, we got to know something else. Here's what they tell you. Watch this. This is a little different. They tell you that that angle right there, G, is 108 degrees, and this angle right here is 72 degrees. Okay? Everybody see that? So, is that enough to say this is a parallelogram? I mean, I didn't say anything about consecutive angles, did I? We had 4 things, right? None of them said anything about consecutive angles. But watch, you got to think a little further. This is where it takes a little thought. Everybody watching? You thinking? Okay. Look at 108 and 72. What if I added those together? What is that? It's 180. All right, that means that these are consecutive angles and they are what? Supplementary. Which means, look, this side right here and this side right here, that's your transversal. What's true about this DG and EF? They're also what? Parallel to each other. Remember that? So if you have consecutive interior angles that are supplementary, which they are, right? 108 and 72 is 180. Okay, they're supplementary. That must mean that these 2 sides are parallel. Now, is this a parallelogram? Yes, because we have one of the theorems. Which one was it? The second one. The second theorem that we did, all right, said that if you had one pair of opposite sides both parallel and equal, then this is a parallelogram. So what can we say? We can say, yes, it's a parallelogram. And I'm just going to write, what would you name this parallelogram? Start at any letter, it doesn't matter. Start at D, probably is a good way to start. We go what? D, E, F, G. All right? So yes, we do have a parallelogram. And that's what they're going to ask you to do. They're going to ask you, is it a parallelogram or is it not a parallelogram? I mean, you could just guess, all right? But would you rather have a 100% chance of getting something right or 50% chance of getting something right? 100, absolutely, okay? So know what's going on here. Don't just take a wild guess and just take a 50% chance, all right? Let's do another one. Let's do this. Let's just slant it just a little bit. All right. Let's say we had something that looks like this. Actually looks more of a rectangle in the book. Let's make it look more like a rectangle. But do I know, sitting there right now, without anything written on this, do I know that that's a rectangle? Do I know it's a parallelogram? No. Okay, I don't know any of that stuff. But here's what they tell you. They tell you a couple things. So if you just see something sitting there, I mean, that sure looks like what? I mean, to our eyes, what would you guess that is? It's not a square. Square has all four sides equal. It's a rectangle. It looks like a rectangle, doesn't it? But can we say it's a rectangle? No, we cannot. All right, but here's what they tell us. They tell you that this and this are equal, and they tell you that this and this are equal. Is that enough to say that that's a parallelogram? Right, that's the thing. Not the opposite sides. Right, the opposite angles. Are the opposite angles equal to each other? No, they're not. Okay? So if the opposite angles are not equal to each other, then this is what? Not a parallelogram. Everybody got that? So you got to think a little bit. Just because they gave you two sets of equal angles does not mean it's a parallelogram, because they're not opposite. If the opposite angles were given equal, then yeah, sure, it would be a parallelogram. But this is not a parallelogram. At least we don't know if it's a parallelogram. Let me give you an example of something that would have these angles are equal to each other, and it's definitely not a parallelogram. Let's change this to white. Watch this. Let's make it about right there. Okay, it kind of looks like a trapezoid, right? We're not really sure if it is yet, because we don't know anything about it, right? I don't know that those are parallel. I don't know anything about it. But watch, what if I did this? I'm going to do the same thing. This is still a quadrilateral, isn't it? What if I told you that this and this were equal? And they sure look like they're equal, don't they? And what if I told you that this and this were equal? Yeah, they definitely can be equal to each other, all right? Does that mean that this is a parallelogram? It's obviously not a parallelogram, is it? All right? So you cannot say that it's a parallelogram. Now, this might be true. Look, all four of these might be 90-degree angles. Do you see that? They all might be 90-degree angles. That means that this and this are equal. And if that was 90 and this was 90, then this and this are equal. So it could be a parallelogram, but is it always a parallelogram? No, it's not. All right, enough of that. Enough of that. Let's go to a next example where we're actually going to put some numbers in here. Now, this is what I really want you to be able to do. All that led up to this. What are we, 21, right? Okay, we got time to do at least one example. It'd be really nice if you guys just stop all the annoying noises and stuff. Well, we're going to be out of here in like 2 minutes. All right. Let's do this. Oops, not what I wanted. Let's do this. Let's do this. And here's what they do. They tell you a couple things. Oops. Let's click off of that. There we go. Now let's make it red. All right. So they tell you that this is 5a. And they tell you this is 20. They also tell you that this is 6b plus 2. And this is 7b minus 4. You knew this was coming, right? Putting these variables in there, doing some algebra. Yeah, it always does. I mean, every time we do something like this, okay, we do some algebra. So let's everybody look. So what I want to do, they didn't tell you it was a parallelogram, okay, but what they want you to do is they want you to solve for A and B in order to make this into a parallelogram. That's a 20. That's a 20. 6b plus 2, 5a, 7b minus 4. Everybody look up here. Hush. So what I want to do is I want to find out what should A be equal to and what should B be equal to in order to make this into a parallelogram. Again, they don't tell you that it's a parallelogram, but you got to find it. Really, this is the same exact kind of problem that you would have on the other lesson, except what they're asking is just a little bit different. All right, so they don't tell you it's a parallelogram, but what should A be equal to and B be equal to in order for it to be a parallelogram? So if these diagonals bisect each other, then it's a what? Parallelogram. So if they bisect each other, that must mean that this needs to equal that. Agreed? So 5a must equal what? 20. Divide by 5, do that in your head. What's that? 4. So a should be 4. What do we do with the b's? Set them equal to each other. Okay, we got to set them equal before we solve. You can't just say solve. You got to set them equal. Let's do this real quick. Subtract 6b, subtract 6b, add a 4, add a 4. That cancels. 7b minus 6b is 1b. This cancels. Very good. It's 6. So if a is equal to 4 and b is equal to 6, then this thing will be a parallelogram. It's almost identical to what we've done in the past, except the question is just a little different. All right? Do we get out at 21 or not? 38. Oh, third period gets out at 21. I knew there was a 21 in there. All right, so we got lots of time. We're only going to do one more example, and that'll be it, okay? Why didn't you go to the bathroom before you came to class? How many times do I say that a day? My dad used to say, if I got paid a nickel every time somebody said that. Anybody hear that expression? If I got paid a nickel every time I heard whatever, I'd be a rich man. That's what he would say. That's what all old people used to say. Nobody says a nickel anymore. All right, we are not finished yet. One more example. Everybody look up here. Do you know that's a parallelogram? No. I've asked that a million times today. Now this one, the math on this one is a little trickier than the math that we just did. Okay? But we went over this yesterday, so I hope you're paying attention. Guy's got attention span of a gnat. Just go from one thing to another. Come on, let's focus. This is the last thing we're doing. If you're writing this stuff down, then you should be paying attention. All right? But see, you have nothing in front of you. You're not writing anything down. That's part of the problem. It's part of the problem. You got it. The problem is that you've been yakking the whole entire time, just making all kinds of noises and everything else. All right? When I've even warned you about sending you out and writing you up every time. It doesn't seem to faze you. It doesn't seem to bother you at all. All right? Come on. Let's straighten up. Become the young man that you're meant to be. All right? And let's do what you're supposed to do. Nobody's laughing. All right, here we go. What we want to do is we want to find out what x is equal to and what y is equal to in order to make this a parallelogram. So how could we make this a parallelogram? Well, if I knew what? That this side was equal to this side, and also knew that this side was equal to this side, then that would make it a parallelogram. So I got to figure out what's the x going to be and what's the y going to be. So let's set them up. So if these two are equal, what would I write down? I would write down 2x equals y plus 14. What would I do here? Set those equal to each other. So I'm going to go y equals x plus 11. Now remember, if the only thing I had was this, is there any way to solve for x and y if that was my only equation? I hope you guys are watching, okay? Because this is going to be on a test. Could be on a quiz. So you need two equations. Remember we talked about this yesterday? If you got two unknowns, you got to have two equations. There's our two equations. So what are we going to do here? We are going to look at this. They tell you kind of what y is equal to. So what we're going to do is take what y is equal to and do what? Give me a good math word. No distributing here. What is it? Oh, goodness. You guys said it yesterday. Substitute, right. You're going to substitute into this, okay? So that's what we're going to do right now, all right? So instead of a y, what are we going to replace it with? An x plus 11, okay? So what I'm going to do is I'm just going to rewrite this. We'll do this down here, okay? I'm going to rewrite this equation, but instead of having a y, I'm going to replace it with what y is equal to, which is x plus 11. So I've got 2x equals x plus 11 plus 14. See what I did? This right here is my y. I just rewrote that top equation, but I replaced that y with what y is equal to, which is x plus 11. And now I can solve for x. Subtract an x from both sides. That cancels. 2x minus x is x equals 11 plus 14 is 25. So x would equal 25. Everybody good? So x is 25. What's y going to be now? I got to solve for y. Well, I got y by itself right here, don't I? Do you see that? What's y equal to? Donnell. Go over, pick it up. Sure it's not tucked in after I asked everybody. So now, what's y equal to? X plus 11. So x is 25 plus 11 is equal to 36. So y equals 36. This can be on a quiz, and it can be on a test. And it's definitely going to be on your homework as well. All right? So I sure hope you're paying attention. I've got like 1, 2, 3, 4 already knocked out. Their heads on the desk, not even looking up here. It's just crazy. I'm not going to get upset anymore. Well, I am going to. Just not going to say anything the rest of this period. It's just very upsetting. It's just not how students act. You got to stay awake. You got to pay attention. And even then I'm saying this, you must be sound asleep because they're not even, your head's not even coming up there. Finally see some eyeballs. You should be ashamed of yourself, really. Absolutely. Okay? You should be embarrassed. All right? You should be ashamed of yourselves for sleeping and not paying any attention at all. That's all I got to say. I said I wasn't going to say anything. I can't help it. I'm sorry. I got to say stuff. That's what my job is. All right. Well, you do have a homework, and it's 18 to 25. So let me see. Let me get my book up here. So it's section 6.3. Let's write it down. Section 6.3. And it's pages, or it's just one page, 267. And it's 18 to 25. I wasn't going to do this, but I think I will now. Tomorrow, we are going to have another quiz. I can do that. I can do whatever I want. We're going to have another quiz. And it's going to cover the same thing that last quiz covered, which is sections 6.1 and 6.2. Not going to have any review for it. So it's not technically a pop quiz, but it kind of is. Because I almost gave you a pop quiz today on 6.1 and 6.2. Almost. But at least I'm warning you now. But I'm not going to tell you what's on it. It's the same kind of stuff that was on the last one with different numbers, different problems. All right? What did I just say? I just finished saying I was not going to review for this. I said, I just finished saying it. All right? I'm not reviewing for this. Okay? The one tomorrow I'm not reviewing for. We've already reviewed. You've already took a quiz. All right? And we got like 6-7 minutes left in this class. So we can take some questions on the quiz I just gave back to you today. And they'll be kind of like this. All right? So you are going to take a quiz on 6.1 and 6.2. And there you go. All right? Okay, be ready for it.